Okay, so this next set of video is going to be about Quaternary landslides. So I am currently situated on top of a fairly large landslide that looms above the southern end of Cedar City. There you can see the Walmart Supercenter and Home Depot, a couple of the hotels, right? And then the university's back in that direction, and then you can see the red hill and the shade over there, right? So I'm standing on these landslide deposits, and what I'm going to do is I'm going to go get a closer look at them so we can talk about how you can tell something's a landslide deposit in person. So what do landslide deposits look like? They look like this. If we take a closer look, I'll walk up here and I'll put my hand in there for scale. First of all, you can see that everything's poorly sorted and arranged in different orientations. The clasts are very angular and they're of different composition. These are not the same formation. That is a different formation. So a lot of this is Cretaceous rock as well, and the Cretaceous rock comes from up the mountain there, basically where you can see the snow. It's not supposed to be this low. And some of that could be due to faulting, of course, but in this case, because of the mixture of sediment or of rock types, their angularity, and their variation in size, as you can see that there's a car-sized boulder there, good indication that these came raging down the hill at some point. This does not look like glacial till. Glacial till has a little bit more sorting to it usually, but that would be another thing you might consider. Is this a glacial deposit? And the history of glaciation in this area points away from that in general as well. If you look at this in maps, you can look at the UGS map portal, Utah Geological Society map portal, and you'll see the lobate shape of these deposits. It kind of looks like a tongue, big fat tongue that came down the mountain. That's another good sign that it's a landslide deposit. As we move out over here and maybe look back towards the south, there's more landslide deposits there. And we can see, if we look up there, there's that fairly steep cliff. And again, this is an area that's full of normal faults. So we have highly unstable slopes created by those normal faults, and maybe by some river erosion at some point when there's more water around. And that would lead to these big landslides potentially happening. So the literature says this one's about 100 feet thick in most places. So that's another thing to know. And it is very unadvisable to build a housing development against the base of a landslide, because if we have a lot of moisture, the base of this landslide certainly could keep moving. So, Quaternary landslides.